Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about how to self-learn the fundamental concepts of data science in 20 weeks. If you are going to ask me, will you become an expert in the fundamental concepts in this 20 weeks? The answer is simply no. Data science is a very long journey. I have 10 years of experience and I still continue to learn. But what will happen is this 20-week program will ensure that you get exposed to enough concepts about data science that will give you the confidence to pursue a long journey in data science. I find that this is the most important thing that many people lack when they are trying to self-learn data science. So first, in order to understand why many people who are trying to self-learn data science quit within the few days or within the first few weeks, this is very important to understand so that you don't quit but you pursue learning data science. The number one reason is lack of clarity. Data science is not a simple topic that can be learned. There are so many different things within data science. For example, programming using Python or any other programming language. There are various packages that you need to learn. For example, Pandas, NumPy, like a Matplot library, Seaborn in case of Python. Similarly, in case of R, there are so many different packages or libraries that you need to learn in order to work on a data set and solve a data science problem. There is no single platform where you can learn everything about data science for free. There are a ton of resources in the internet which are available for free, but it's very hard for you to identify what are all the best resources that are beginner friendly. It is very easy to get lost in the detail while you are learning data science, and especially when you are trying to self-learn data science, it's very hard for you to track your progress. People who are signing up for a professional master's degree in data science or professional course in data science, it's easy for them because all these problems are sorted out for them. They have a structured plan, they have a support system which can help them in case they have any issues or troubles, and in case of finding a job, they have an alumni network and to contact with the industries that will help them to find a job as well. But for people who are trying to self-learn data science, it's quite hard. So in this video, I'm going to tell you how to make efficient use of your first 20 weeks that will give you enough confidence in order to pursue a career in data science. So let's get into the topic and then see how you need to plan your first 20 weeks while starting to learn data science. The week 1 to week 3 should be spent in learning the programming language. You can choose either R or Python programming. If you are a beginner and do not have much exposure to programming language, I would say you start with Python programming. Why? Because as per the Kaggle survey, 80% of data scientists use Python primarily in their job. So there are so many different people who are using Python, and then the other advantage is Python has so many different packages and it has a huge support system. So it's very easy for you to progress when you are using Python. Even if you are stuck with an issue, it's very easy to find a solution online. So now, why Python programming? Why you need to learn programming in the first place? Because everything that you do in a data science project, right from reading the data, doing the analysis, building the model, measuring the performance of the model, extracting various insights, performing various statistics test, for everything you need to know programming, and hence you need to spend enough time to become better in programming. So within these 3 weeks, you will learn enough concepts that will help you to understand about what is Python programming, but you need to ensure that you continue to practice more in order to become someone who is good in programming language. So if you are going to go with Python, so some of the things that you need to learn are, these are all the various topics that you need to learn. So you need to understand about the basic syntaxes, and then you need to know about the various data types, especially the collection data types, which is very important because depending upon your understanding of the collection data types, it will be very useful for you to know what are all the different data types that can be used for different scenarios. And you need to know about the control flow, and you need to know about the loop and iterations, various iterations, and finally how to define a function, how to use a function, and how to make use of lambda functions. So these are all the various basic fundamental concepts that you need to learn. So if you are wondering where to start learning Python programming, one of the best place to learn Python programming would be Kaggle. Kaggle has an introductory course to Python programming, which is, I believe, a 5-hour course that will give you enough exposure to various topics in Python programming. After covering that, there is an interactive platform where you can learn Python programming for free. So I will provide a link to these two places in the description. So if you are learning Python programming, refer to these places, which are excellent places to start learning Python programming. Once you are comfortable with the Python programming language, it is time to move on to the next step, which is the Pandas library. Do not wait until you become an expert in the programming language. That doesn't happen in the first few weeks or the first few months. Once you are comfortable with the various topics that I have mentioned, it is enough for you to move on to the next step, which is the Pandas library, in case you are using or you are choosing to learn Python. So why is Pandas important? Pandas is very important because it helps you to work with the data and manipulate the data. Any data science project, you will have a data set, whether predictive or non-predictive. It can be insights driven, but whatever it is, one thing that is for sure is you have a data set on which you need to work on. In order to work on a data set, what you need is you need an package library, which is Pandas. You need to know about the different functionalities of this particular library in order to perform the analysis to the best extent. So what are all the different places where you can learn about the Pandas library? The one important place is the PyData. PyData has an excellent article which explains about the various key concepts of the Pandas library, the common functionalities that are being used, the scripts, and how the output would look like, how the data is being transformed. So you will learn about the various concepts. After going through that article, the next step is to do a short Pandas course, which is available on Kaggle for free. So again, this will take you maybe 5 to 6 hours to complete, but this will give you enough exposure to the different concepts of Pandas library. After learning from these resources, the next step is to do as much as self-learning as possible using the data set. So what you need to do is you need to identify one data set that is most interesting to you. For example, if you are interested in, let's say, housing data, then what you need to do is you need to download an housing data, and then you need to try to solve or try to get answers for various questions. For example, what is the average price of the property in different locations, maybe based on state or based on a specific pin code, and what are all the different factors that impact the price of a property. Does age of a property have an impact in the final price to which the property has been sold to? And having a school nearby or a freeway nearby, does it have an impact in the overall price of a property? So these are all the various factors that could come up in anyone's mind, and then you need to find the answers for these questions by working on the data set, by making use of the Pandas library. That will help you to learn about the Pandas library. So if you are wondering what are all the various things that you need to cover in the 3 weeks that we have allocated for Pandas library, so the various things that you can learn about Pandas are here. So these are all the various fundamental concepts that must be understood by you. To start with, you need to know how to create, read, or write a data frame. You need to know the selection and assignment. If you're working on an housing data set, if you want to understand about the prices of a property in a specific location, you need to know about selection. If there are any missing data or missing data points, then you need to make use of assignment in order to maybe assign a suitable values to them. Then you need to know about aggregation and group by. If you want to, let's say, understand about the average price of a property in a location, you need to make use of aggregation and group by to get those results. And there will be a lot of missing data in your data set, like in any data set, in any data science problems that you work on, it comes with various issues. One of the most common issue is missing data. So you need to know how to handle the missing data. You need not know about the all the different ways to solve the missing data point problem, but you need to know about what are all the different options that you have and how to make use of them. Maybe some simple techniques to start with. And finally, merging data set, when you're working on a data science problem, the data set will be present across different systems, or some data would be available to you directly on a platform, and then there would be some data which you need to extract from a different platform, or you need to extract online. So ideally what would happen is when you work on these data sets, you try to merge different data sets and then work on them. So you need to understand how to merge different data sets, what are all the various techniques that can be used. You need to know about what are all the so the use of a summary in the Pandas library, which helps to understand about the data set that you are working on. What is cross tabulation? What is pivot? That are quite useful in order to understand the relationship between like 2 or 3 attributes in your data set. So to start with, these are all the various topics that you need to learn in Pandas. So from week 4 to week 6, you need to spend enough time in covering all these different concepts of the Pandas library. Week 7 to week 9, we are going to learn about working using an array or working on an array. So from week 1 to week 6, we have learned about the basic Python programming and the Pandas library. So the next step is to learn about NumPy. NumPy is very useful when you are going to work on a numerical array. In case your data set is not having like a numerical array or have as a lot of categorical data, it is easy for you to convert them into a numerical data and then make use of a NumPy. NumPy is very useful in order to perform like a high-speed computation, and it's made efficient use of the memory, and hence it is so popular when you have to work on the numerical data. Not only that, NumPy is used in Pandas, in Matplot library, as well as scikit-learn and so many different packages too. So NumPy is one of the most efficient ways in order to work on an numerical array. So now coming to learn NumPy, like where can you learn NumPy? There are 2 excellent resources where you can start with. So one is present in the NumPy website. It's an excellent article which explains about the various fundamental concepts of NumPy and how they are useful and how the output is transformed or what kind of operations are performed. And then there is one more in Better Programming. I will provide the link to both of them in the description. So these 2 would be really good for you to understand about NumPy. So after going through these 2 articles, the next step is to ensure that you spend enough time to learn the fundamental concepts. So what are all the fundamental concepts of NumPy? So here are the fundamental concepts of NumPy. So you need to learn to create 1-dimensional, 2-dimensional and 3-dimensional array, and if you are interested, you can learn how to convert an 1-dimensional array into, let's say, 2-dimensional or 3-dimensional, and how to convert a 3-dimensional array or 2-dimensional array into an 1-dimensional array. That will help you a lot in understanding of what are all the different arrays and how they look like and so on. The next step is to understand about indexing, slicing and joining. So when you work on a numerical array, there could be multiple arrays. So you need to understand like how to index, how to get the value from a particular location, for which you need to make use of indexing, and how to join, like, let's say, different arrays. When you have a large array, you need to understand how to slice them into small arrays. So these can be learned by using these concepts. The next one is iteration and manipulation. So when you have an array, you need to know like how to iterate through them and how to manipulate them, how to perform various operations on them. And the next one is sorting, searching and filtering. So these operations will help you to better explore a numerical array. And finally is the mathematical and statistical operations that can be performed on an array. So NumPy is very fast, and if you are making use of NumPy in order to perform various mathematical and statistical operation, it will be much more efficient because it makes efficient use of the memory. And so I would say from week 7 to week 9, you need to spend enough time to learn all these topics, and because these are all the various concepts that are most frequently used when you have a numerical array. This will help you to get started with Python and NumPy. So now coming to the week 10. So week 10, you need to dedicate the week to learn about visualization. When you work on a data science problem, the 2 important factors are like how best you are able to understand the problem and how best you are able to communicate the problem. In order to do these 2 in a very good manner, you need to learn about visualization. You need to understand what are all the different visualization techniques that can help to understand, like that can help you to better understand the data, and that can help you to better communicate the story to an stakeholder. There are different packages for visualization. To start with, you need to understand a Matplot library. So Matplot library is a highly customizable. You can almost do whatever you think with the data and for the visualization. So it is very customizable and very useful when you want to like maybe create an unit chart with all the information that is possible to better explain it to maybe a stakeholder or to a team. The next one is a Seaborn library. So Seaborn library is not so customizable, but it is very useful when you want to perform a lot of analysis. For example, when you are working on the data, you don't have time to customize how the visualization or the chart look like. So Seaborn is especially used for this particular purpose. So you can't customize much, but it's very quick and easy to build various visualization with just one line of code. All you need to do is you need to pass on the data set, the different columns that you want to analyze, and what kind of chart you want to produce, and it will produce the output in an fashion which will be very easy for you to understand what's happening, what are all the various patterns on it. So especially when you work on data analysis, like go for Seaborn. And finally, like learning to build an interactive chart. So this is especially useful when you want to, let's say, not only share an static image to a stakeholder, but give the option for the stakeholder to play around with the data. So in those cases, you need to make use of an interactive chart building library such as Bouquet, which can be used so that you can share an interesting data set to a stakeholder or to a business stakeholder who can play around with the data without much of technical knowledge. Next one is week 11 and week 12. You need to focus on learning statistics. Statistics is used almost in every single phase of a data science project. The descriptive statistics is very useful for you to understand about the data, to see how the data is distributed, to understand about the summary of the data set. And inferential statistics is very useful in order to get the insights out of the data. For example, if we take a housing data set, what are all the various factors that have an impact on the price of a property? To understand if a location of a school has a better impact as compared to proximity to an freeway. To understand about these questions, you need to learn about inferential statistics. So it helps you in understanding the data and extract various insights out of the data. So statistics is not something that can be covered or that can be mastered in few weeks. There are people who are doing like a bachelor's degree and master's degree and PhD in statistics, and hence if you want to, if you think you can master statistics in just few days, trust me, you are not going to. But what you need to do is you need to ensure that within the 2 weeks, which is week 11 and week 12, you need to learn the important concepts. So what are all the important concepts? Here are the important concepts in statistics. So you need to learn about the descriptive and inferential statistics techniques that helps you to understand better about the data and to extract the insights out of the data. So some of these techniques within a descriptive and inferential statistics. The next one is what are all the different distributions of the data set. So when you have a data, so you need to understand how the data is distributed. It is very important because it has a lot of importance to choose what kind of algorithm you need to use. Depending upon the distribution of the data set, the choice of algorithm could change. The choice of analysis could change, and hence it's very important for you to understand what are all the different distributions so that you know how your data is being distributed. The next one is central limit theorem and margin of error. So these two are very important concepts that helps you to understand about some of the concepts of statistics, to better understand about your data set. The next one is the central limit theorem and the margin of error. These techniques helps you to better understand about your data set. And the next one is confidence interval and the confidence level. There is a difference between confidence interval and confidence level. You need to know what is confidence interval, what is confidence level, when to use what, and this is a very important question that is frequently asked in many data science interviews. The next one is causation and correlation. You need to know the difference between them. A lot of people misstate that correlation is causation, but it is not. Causation and correlation are two different things. Causation is one particular thing that is causing the other activity, whereas correlation is it simply means that there are two activities which happens simultaneously, more likely to happen together, but one of them is not triggering the other one. So you need to know the difference between the causation and correlation. And the last one is the basic statistic test. For example, t-test, f-test, rest wire test. So these are all the various statistical tests that you need to understand. So these concepts can be definitely covered in 2 weeks, and you need not spend too much time to become and master in all these concepts, but you need to be sure that you understand what are all these different topics. That will be enough for you to get started. Next, from week 13 to week 15, I would say you need to focus enough on learning the structured query language. Many people who are trying to learn data science, they fail to learn about SQL, but it is most important. Why? Because in most of the corporate environment, the data would present in a database or in a data platform. And in order to work on the data set, you need to know about the querying language. If you understand SQL, so if the data is present, let's say in a relational database, or it is present, let's say in Hadoop, in both the cases, like if you know SQL, it should be good enough, because in case of Hadoop, like you can make use of Hive, the query, the syntax are pretty much very close to SQL. So for anyone who is going to who wants to see a career in data science, I would definitely say you need to spend enough time in learning SQL. A lot of people who are coming from an academical background don't usually get enough exposure to SQL. So you need to ensure that you can make use of some excellent platform. For example, Mode is an excellent platform which can be very helpful for you to provide various scenarios, and it's an interactive platform where you can learn to code. One problem with SQL is you need to have a database in order to work with it, to learn SQL. Many people do not have access to a database. When you install MySQL, it by default comes with a small database, but it's nowhere close to how a real world data set would look like. So what you can do is you can make use of these platforms such as Mode, which offers you a free platform where you can make use of it in an interactive window. You can assume various scenarios and then try to come up with many complex queries that will be quite similar to what you see in a real life scenario. And then Kaggle offers 2 different courses on SQL. One is a basic course and one is an advanced course. So these 2 courses are really useful for you to learn about SQL. So now coming to the final part of this particular journey, from week 16 to week 20, you need to spend enough time to understand about the data analysis and feature engineering. Data analysis is one of the most important thing for a data scientist. In whatever scenario, in whatever data science problems that you might take, data analysis is very important to ensure that you are able to extract all the insights out of the data, and you are able to communicate the story to a business stakeholder. So in order to perform or in order to learn the data analysis, you can't learn much from listening to a video or maybe listening to a lecture. So you can learn about data analysis only by practicing more and more. So for those who are going for a structured learning program, there is not much of a difference between them and those who are self-learning data science. Those who practice more learns more about the data analysis and feature engineering. So how you can learn? There are some good articles that can help you to understand about data analysis, how and data analysis should be performed. It's kind of a template. So when you are given a data, so you need to start with understanding the data. So there are some basic things that you need to check, like univariate analysis to see how the different attributes are distributed, and then maybe bivariate analysis to see a relationship between them, and then multivariate analysis to see in combination is there any patterns in it. And then slowly there are different techniques that can be used in order to extract the insights out of the data. So there are some good articles. I will provide the link to those articles that will help you to understand the steps in the data analysis. And what you need to do next is you need to download as many data sets as possible from Kaggle or any other resources, and you need to work on these data sets, try to come up with various questions, get various insights out of it. And the more you work on a data set, the more you learn about data analysis. The next part is feature engineering. So whenever a data has been provided to you, the data is usually not in a format that is readily consumable by let's say a model. So this is especially when you are working on a predictive model or a problem where you need to make use of an algorithm. So in those cases, you need to transform the data. So what you do here is you make use of feature engineering techniques in order to transform the data from one format to another format that makes it easy for you to make use of an algorithm. So what are all the various feature engineering things? There are a ton of feature engineering techniques, and to start with, you need to maybe learn about these feature engineering techniques. So they are binning, scaling, and one-hot encoding and lot transformation. So binning is especially useful when you have, let's say, an numerical data with a large range. So you want to combine them and group them into different buckets. So you can make use of binning for it. And in binning as well, you can define like how you want to define it. Let's say you want to put them into equal buckets, like the number of data points to be present in a particular bucket to be equal across all of them. So accordingly, you can make use of a suitable binning technique, or you can come up with an fixed frequency. So you can use different techniques, but binning is a very important technique when you want to break them into smaller pieces. The next one is scaling. So scaling is very useful, especially when you have a data set which has various numerical attributes in different scales. For example, age and salary. So these two are in huge scale difference. There is a huge scale difference between these two. So when you make use of a distance-based algorithm, in those cases what happens is those attributes which are present in a higher scale will have a higher influence. So in order to avoid that, you can make use of scaling to bring all the attributes to a consistent scale. The next one is one-hot encoding. For example, when you have an non-ordinal categorical data, so in those cases, when you make use of numerical encoding, for example, let's take a gender as an example. So there is no sequence between it, like male and female are two different parameters, and there is no sequence in between it, like one doesn't mean higher or the other one doesn't mean lower. Especially, and the same thing with let's say city or country. So all the different countries or different cities, there is nothing like which is making one superior and one making the other inferior. So in those cases where we have a non-ordinal categorical data, in those cases when we use numerical encoding, like for example, let's take like if we encode them into an integer, then what happens is when we use them into an algorithm, it will try to extract pattern out of it. It will try to see whether a higher number means something special or lower number means something special. So in order to avoid that, what we do is we make use of one-hot encoding. So you need to learn about one-hot encoding. That will help you a lot in transforming the data into a right format. The next one is lot transformation. When your distribution of the data is not in a format that is suitable for you, then you can make use of transformation such as lot transformation to transform the data. So these are all the various basic things in feature engineering that can be very helpful to start with. These are the commonly used techniques in majority of data science problems. So this should be good enough for you to get started off. So that's about the plan, the 20-week plan to learn about the fundamental concepts of data science. So if you are interested in detailed various resources to learn the fundamental concepts of data science, if you want access to like free excellent resources with assignments and with interview questions with problems to be solved, so I have a template on Notion, so which is very useful for beginners to learn data science, and it is easy for you to learn as well as track your journey. It has a simple tracker too. I will provide the link to the course in the description, so if you are interested in self-learning data science, that can be very useful for you. And that's it about today, and I will see you in another video. Bye until then.